breakthrough cybersecurity technology, combining cyber deception and threat intelligence.
Good morning, I am Dr. Milan Patnaik. I am the CISO of WhizHack Technologies Private Limited, and I also head the Global Services Division in WhizHack.
Today, we'll be discussing questions about deception technology and exploring what WhizHack has to offer. How do you define deception technology and how does it differ from traditional security approaches?
Traditionally, security, as we all know, is divided into multiple layers. So we call it defense in depth. So few years back, all the layers of security were restricted inside the network. So the outermost layer was the perimeter. Then we go inside the network towards the endpoints. But gradually, with the increase in the threat vectors and the complexity in the attacks that has taken place, and the large number of attacks that has been explored in the recent past, there is a requirement where proactively we have to detect this attack to save our network from such complex attacks. So therefore, additional layer that is required today, that is called the deception layer, and this deception layer is a layer which is outside the network perimeter of an enterprise. So this deception layer is actually what is forming the part of the deception security for the network, and all the technology that is installed in this layer, they form the deception technology. So in that case, deception technology is combining all the activities that we do proactively, sitting outside the enterprise network, and give forewarning to the security team that something is going to happen, which can vary from 2 to 24 hours advance notice.
What type of deception does your solution offer?
WhizHack, we've been pioneers in the deception technology. I can tell you that because when the world thought about deception, we started our first product, and the product is called TRACE. TRACE stands for Threat Reconnaissance and Classification Engine. So what TRACE does is, TRACE is a agent, you can call it as a sensor, which sits outside the network in the layer which provides deception, as I explained you, and it gives forewarning of any attack which is happening onto your network. So TRACE primarily consists of three things. Firstly, it has a set of protocols which are emulating the complete enterprise network in form of a honey net. So basically, it's a honeypot, a group of honeypot, which is called a honey net inside the trace, that gives a false emulation of the network to the attacker. Second, it also does deep packet inspection on the attack vectors and generates threat intelligence. So therefore, it's called a threat reconnaissance engine. And also, what it does, it creates a complete deception layer in form of threat intelligence generation and deception to generate the attacker signature. So that is the solution that WhizHack can provide as far as deception is concerned.
What are the advanced features available in your deception solution?
If you look at current deception technology that is available in the market, they are only handling the problem of a decoy. So that is, they all provide a honeypot, and the work of the honeypot is to divert the attack which is coming to the enterprise. So, hence the challenge remains that once the attack is diverted, and what is beyond that. So, as far as WhizHack solution is concerned, we added that extra layer which you are pointing out. That once we realize that there is an attack which has come to trace, we carry out deep packet inspection of the attack packets and generate a signature. And this signature, which can be in any standard global threat intelligence feed format like the sticks format, and it can be fed into existing SIEM or SOAR solutions which are there in the market to augment the threat intelligent library of that solution. So TRACE, yes, it provides a decoy as any honeypot provides, but it also adds this additional feature that it provides threat intelligence feed in form of signatures, which can be updated on any standard format based solution like a SIEM, SOAR, etc.
Can deception technology be seamlessly integrated with existing security solutions?
As I said, our deception solution is called TRACE. TRACE has got two very unique features which is not available or maybe not reported by many such technology in the world. First, the biggest challenge that such a deception oblique honeypot solution has been facing over the years when you start looking at it is that the attackers are able to detect the honeypot, and once the attacker detects the honeypot, then the essence of this deception reduces, because then the attacker bypasses the honeypot and starts attacking your network, and the forewarning activity that is supposed to happen, it does not happen thereafter. So this challenge of detection of a honeypot is handled by a unique technique that we have, for which we have filed a patent also. It's called dynamically intelligently shifting sensors, DIS. What we do is we change the signature of the sensors which are there inside the honeynet in an algorithmic fashion, so that the attackers are not able to detect that it is a honeypot or a honeynet which he is attacking. Of course, it's very difficult to keep the attacker, fooling the attacker for long. So, but it is we have been able to achieve this technique for long enough so that we can generate the threat intel or the TTP of the attack vector that the attacker is using. So this is one unique feature that we have in TRACE. The second unique feature is ultimately over a period of time the honeypot gets detected, and let's say somebody destroys it. So we have a feature called self-healing, where our honeypot automatically heals itself and restarts and reboots once it is destroyed, to start acting as a new signature and again doing the same activity that it is supposed to do, which is meant for. So these two features of self-healing and dynamically intelligently shifting sensors are the unique features that WhizHack's solution provides as a deception technology.
How often is the system updated, and how are updates handled?
The deployment of our deception technique using TRACE is twofold. It can be deployed outside the network, as I explained, as a pure deception layer. It can also be deployed inside the network to detect any east-west traffic, as we call that, malware, lateral movement, etc. So let's look at both of them separately. If you take the case that the deception box or the TRACE is deployed outside the network, then it's frequently updated whenever the signatures are received from multiple such solutions which are put in the environment. Before we actually started delivering this box as a product, we deployed our TRACE in various parts of the world where we wanted to capture the attack vectors. So we have a long set or a deep library of such attack vectors which are present, and hence that is used to update all the TRACE which is deployed in any of the enterprises outside the network dynamically through our central server engine which is on the cloud. So as far as TRACE external is concerned, it is dynamically updated very frequently based on any new signature that we get from other TRACE devices, or we also take various other rules that we get from global threat intelligence providing networks. Coming to TRACE, if it is put inside the network, then it can be again twofold. Either the network is an air gap network or the network is a connected network. If it is a connected network, then it leverages the same process as I discussed about the external TRACE, because it is updated from our memory as well as any global threat feed. But if it is a disconnected network or an air gap network, then the update happens physically through one of the server which is deployed inside along with the TRACE, which is called the collector, and the collector collects all the information and creates and houses the library of this threat intelligence. So it's done physically in air gap network. So, to summarize, you can say that the updates happen dynamically through the collectors if it is connected, and if it is in an air-gap network, it happens physically by updating the collector which is inside the network.
How do you define dynamic shifting intelligent sensors, and how do they differ from traditional security approaches?
Okay, when we started designing Trace, we started to look at why honeypot solutions are not doing well in the market. So honeypot as a solution was maybe started with Ativo, and then various other solutions came into being. But most of the clients at those times, they said that okay, we have a honeypot solution, but nothing is coming out of it. So there can be only two problems in that. So either your honeypot is detected, of course, that the attacker does not look at your honeypot, so you don't get any data from the honeypot, or you are very good, nobody is attacking you. So which is a very, very bleak case. So we consider that, let's say, if a honeypot is not giving any data, that means the attacker has detected. And then we started understanding the attacker psychology. Just to give an example that unless you see how attacker tries to find the honeypot, we will not know how to defend it. So we went into the attacker psychology, and being in the field of attacking for 25 years, we could lay down the various signatures that the attacker will have. And then we thought that okay, the only way to avoid a honeypot or make a honeypot solution successful is to prevent it from getting detected. So the only buzzword which prevents everything is to make it intelligent. So we wanted to add some intelligence in the sensor so that it does not give a fixed signature. So therefore we implemented a honeynet, and in the honeynet these protocols keep changing, which gives a different signature. But not only this dynamically intelligent shifting sensor, it allows or prevents detection, it also adds one new feature. To understand what is the attack TTP, or to understand and do a packet inspection of the attacker packet, you need to capture the attacker in the same PC or the box for some time. Now that time is required, and this time is decreasing day by day because the attackers are able to detect decoys faster and faster by every day. So you need to catch the attacker in the box, right? So to do that, again, this dynamically intelligent shifting sensors have helped us to catch the attacker for at least the time that we can do a DPI on its packets, and hence overall it has been very, very advantageous to our solution in two ways, as I explained. First is to avoid detection, and second is to understand and capture the attacker to understand what the TTPs of the attacks are.
What unique power does ZeroHack TRACE provide to users?
Okay, as I've been explaining in my previous questions, that Trace is different because Trace is not only just a dumb decoy like many honeypots. Trace is an overall solution. Trace, one of the part is a honeypot or a honeynet, you can say, again, which is having this and self-healing capability. But the major part, it has got the capability to generate the threat intelligence, and by doing DPI on the attacker pickup files, and this is what is helping to augment the security posture of your other systems which are running, or solutions which are running in the network, whether it's a SIEM, SOAR, it can be even a next generation firewall which can take in the threat feeds in form of signature. So when I said Trace, it is having a deception capability, but I would say that this deception, which is giving a forewarning of 24 hours, is also augmenting all the existing solutions which are there inside the network to make the network more and more strong and preventive against the latest attacks. So that's the uniqueness of Trace as a solution.